Okay, so I'm going to go through a quick little tutorial here on how to use the LibreOffice Calc solver using a little example problem here. So there's a hot tub retailer and installer that purchases and installs hot tubs with an accompanying water pump and corresponding length of tubing for each model type. Each hot tub fetches a different amount of profit and requires a different amount of labor and tubing. But it requires the same amount of water pumps, just one water pump for each hot tub. So you can read the top here or whatever, and basically just this all translates down into your objective function and the constraint function. So each hot tub, the first model generates a $350 profit, the second model generates a $300 profit. For the pump constraints, it's just a coefficient of 1 because each one just requires one and only one pump, and there's going to be 200 pumps to go around for the next production cycle. And same thing with labor and tubing and all that. So you have 9 hours of labor required for Model 1, 6 hours of labor required for Model 2, and there's 1,566 hours of labor anticipated to be available. And same thing with the tubing. So you have 12 feet of tubing for the first model that's required and 16 feet of tubing that's required for installing the second model. And there's going to be about 2,880 feet of tubing available total. And then there's some non-negativity constraints for each hot tub because, of course, you can't have a negative amount of hot tubs to maximize your profits. So that's what this is right here. So 1x1, 1 times x sub 1, the number of Model 1 hot tubs has to be greater than or equal to 0. And the same thing for the number of Model 2 hot tubs has to be greater than or equal to 0. So translating that into a spreadsheet, we have the amount of profits. We have the coefficients here. So $350 profit for Model 1, $300 profit for Model 2. The total profit is going to be right here. And that's going to be pretty much the objective function. These are going to be where our variables are, though. We're going to be highlighting this for the solver. So this is going to be set equal to this, the product of this here plus the product of this here. So the number of Model 1 hot tubs times the amount of profit from the Model 1 hot tubs plus the amount of Model 2 hot tubs times the amount of profit generated from the number of Model 2 hot tubs. Not a big deal, right? And then, of course, here for constraints, number of pumps required for Model 1, amount of hours of labor for Model 1, amount of feet, and same thing with the coefficients here for Model 2. And that's pretty much the same exact thing as you saw before. Here will be just a sum of products. So you have number of pumps required times the number of hot tubs, because of course each hot tub comes with its accompanying number of pumps, accompanying number of labor, and accompanying amount of tubing. So that's the same thing here. That's the only thing that really changes. You just have this cell multiplied by whatever it is that you're doing, whatever you require for Model 1, and same thing for this guy right here, which is why you just add that. So you take this times this plus this times this for your pumps, and same thing with labor, and tubing, right? And of course, these are your constraints here, your right-hand side constraints here for your amount of pumps available will be 200, amount of labor available in terms of hours, and amount of tubing in terms of feet of tubing, right? Okay, so now what I'm going to do is I'm just going to go through the process of solving. So what you do here in LibreOffice is you go under Tools, then you scroll down to where it says Solver, which is right below GoalSeek in this case for the current version. So you click Solver. And their target cell is going to be your output. So it's going to be the maximum profit in this case. So whatever your maximum profit, whatever your result's going to be, is going to go into the target cell. So in this case, we're going to put this right here below the label total profit here in D5, right? So what you do is you just click this little thing. For some reason it says shrink. Don't pay it too much mind. So you click here, right? That's what you just use the little buttons here. So you just click the cell, and for whatever reason you can't immediately hit enter. You have to actually click in here so that this lights up orange on the periphery, and then you hit enter and it'll go right in, right? So that's what you do, and you just click these little things. They'll say shrink or expand or something. That's just some kind of weird archaic issue with LibreOffice. Don't know why. It's just LibreOffice. In this case, we're going to be optimizing the result to maximum. So that's selected here, thankfully. It's not going to be minimum or value of. It's just going to be maximum. And by changing cells, so these are going to be the variables for the objective function, right? So click here. And what we're going to do is we're going to select these two, so number of model 1s and the number of model 2s. So it's just going to be B4 and C4 in this case, right? Hit enter. Yep, click that, hit enter, and that's going to be our objective function that's going to be modified. And then we're going to do the constraints. So thankfully it is set to less than or equal to, as you can see right here. So I'm going to select the amount of pumps that we're going to be using. So pumps required, amount of pumps used right now. This is what it's going to be looking at for the constraints. So this will be the left-hand side of the constraint right here. Number of pumps used is going to be less than or equal to 200. So in this case, I'm just going to collect the cell right here. And same thing with the labor, amount of labor used. Expended, or really expended is the proper way of saying that. And this amount available, labor available, just going to click here, right? Going to be less than or equal to that. And same thing for the tubing, right? Click here again, click over here, 2,880, right? So that's all set up. Now what I'm going to do is I'm going to set up the lower bound or non-negativity constraints. So what I'll do here is I'll click first one, so the number of hot tubs for model 1 hot tubs can't be negative, of course. So what I'll do is I'll say go down here to the operator, make sure it's set to equal to or greater than equal to. So it's going to that amount, and hit 0, right? Just type in a constant of 0. You could also type in constants here in their value too if you really wanted. But this is more general, and in case you have anything more dynamic or something changes, it's probably better practice just to do this. For non-negativity constraint, of course, it's just going to be greater than or equal to 0. So have that for the model 1 hot tubs, and do the same for model 2. So number model 2 hot tubs, same thing, greater than or equal to 0, right? And this is all worked out now, and we just click solve. There we go, solving successfully finished. And the result is $66,100 profit. Yep, that's all correct. So the number of Model 1 hot tubs in this case is 122, and along with 78 Model 2 hot tubs, and generates a total profit of $66,100. That's your maximum amount. So yeah, hope you like this. Hopefully this helps people get started with using LibreOffice Calc if you don't want to use Excel or whatever. There's just one more possible tool that's available. And I'll include this little document here, the LibreOffice Calc and LibreOffice Writer documents here, so that you can practice. I'm going to delete these two, so I'll have this available. Actually, I've already uploaded this to the GitHub, but yeah, and I have little solved sheets. I have two different sheets here. So the first sheet is going to be like this. It's going to be blank, so you can basically just get acquainted with using the solver. The functions are already written in, as you can see. This is already included, so you don't need to pop in the function or whatever. This is just I would just want to include the document so you can just quick use it to get acquainted with something if you're like trying to get a work done, something like that. And back check if whatever. It also just gives you something interactive to play around with too. A starting point if you want to mess around with linear programming. And yeah, so there's one sheet here for practice, one for solve, just so you can back check and see that it's the proper amount. And I'll include this right here to give you background on what this is referring to. So yeah, and if you want the book, again, it's by Cengage Learning. It's titled Spreadsheet Modeling and Decision Analysis. I think this is what, the 9th? Yeah, 9th edition. Doesn't honestly matter. I mean, you can grab just about any of these things. This is like from the 3rd chapter, I think. And yeah, I would recommend just getting like probably the 8th edition, just because I've seen those things going for I think like $20 to $40. This I picked the book up for like $60. Just get the easy the earlier version, because all they do is they jumble the problems around. I mean linear programming was developed back in the 1910s, I think, in the Soviet Union and stuff. This is nothing new, So don't worry about paying too much money for the latest and greatest version. They just jumble it around so professors can charge kids charge students a arm and a leg for these stupid books. Anyway, get off the soapbox here. So thank you for watching, and take care.